Topologies are the spatial relationships between geographic features. They enable advanced spatial analysis and play a fundamental role in ensuring the quality of a geographic information system database, or geodatabase. The geodatabase is an open storage structure for storing and managing GIS-related data in a database management system. In the geodatabase, a feature represents a real-world entity, such as a parcel, building, streetlight, river, or customer. A group of similar features is called a feature class. Within the geodatabase, topologies manage and ensure the integrity of features between feature classes. A topology is used to manage shared geometry, define and enforce data integrity rules, support topological relationship queries and navigation, support sophisticated editing tools that enforce the topological constraints of the data model, construct features from unstructured geometry. A topology is implemented in ArcGIS as a set of integrity rules that define the behavior of spatially related geographic features and feature classes. ArcGIS also includes a collection of editing tools. They allow you to edit shared geometry and help discover errors in the spatial relationships based on the rules you have applied. In this example, we will create a topology. ArcEditor allows you to select the feature classes you want to participate in a topology, as well as the priority ranking for each feature class. This controls how vertices are snapped during validation. ArcEditor also allows you to define topology rules that best describe the data you are trying to model. For this land-based topology, we will use 4 rules. Parcels must not overlap. The boundary of parcels must be on parcel lines. Buildings must be on a parcel. Buildings must contain an address point. Notice that these rules define the relationships between features like parcels, buildings, and addresses, not geometric primitives like polygons, lines, or points. With ArcEditor, topology validation is a discrete operation that can be independent of your data creation and management. You decide when and where topology rules are evaluated. Once a topology has been validated, you can get a detailed report on the topology rules that were violated. Now we will correct some of the topology errors. Topologies can be displayed in ArcEditor like any other layer. You can generate error and exception reports, view topology rules and feature classes, and control the display of errors and exceptions in your map. The Fix Topology Error tool allows you to visually correct topology errors. This tool gives you the option to fix the error, mark it as an exception, or leave it. Here are 2 overlapping parcels. Now that we are aware of this error, we can merge the overlapping area with the appropriate parcel. Validating the current extent shows that there are still other errors that need to be dealt with. Using the Error Inspector, you can search for specific types of errors and apply automatic fixes to 1 or more errors. In this example, we are creating a parcel line on a parcel boundary and making 2 of the secondary buildings exceptions to the buildings must contain an address point rule. You can also leave errors in the geodatabase for correction at a later date. Now we will use ArcEditor to change the length of 2 parcel lines and adjust all connected parcels and parcel lines accordingly. First, use the normal editing tools to change the length of 2 parcel lines. Then use the Topology Edit tool with the ArcEditor snapping environment to simultaneously move 3 parcel lines and 2 parcels to the new location. The Shared Features tool shows that connectivity and adjacency of the parcels and parcel lines were maintained during this edit. With ArcEditor, it is easy to maintain topological relationships while editing. The benefits of defining a topology in the Geodatabase model include better data management, because you select which feature classes participate in a topology. Workflow flexibility, because you define how and when topology rules are applied. Improved data integrity, because you specify the appropriate topological rules for your data. And scalability of topology validation, because you can validate extremely large and complex datasets with the same relative performance of small, simple datasets.